Welcome back. Announcements. Today, it will open your last assignment. I am going to talk about it. The last part of the slides is going to be about your assignment. I am asking you to do one more assignment so we can have 6 assignments, 6 quizzes. It's a very simple one. I am asking you to use the EMF tool and create a class diagram. So I am going to describe the details. It's something very, very simple. You can do it today, tomorrow. It's something that you can do in a couple of hours. It's just for give you the chance to practice with this tool. However, as usual, I am opening the link for a week. So it is due in 1 week, next Monday. Not because you need 1 week, but because you have a full set of 7 days to decide which is the best day for you to work on the assignment. In a few hours, you can finish. So if you send me an email next Monday asking me for an extension because you have exams and other things, the answer is no. No extensions, due date, 26, you can finish in a couple of hours. The sooner, the better. That is my recommendation. Anyway, April 26th, due, your last assignment can be done in hours. You have a week. Useful for you to organize. Now, with that, the final. The other thing that we have this week, final exam, next lecture, Wednesday. No lecture, you do not need to connect to Zoom. Today is our last meeting in Zoom. So the next one, 1:30, Wednesday, your final exam. Just like the midterm, same tool. You need the Respondus browser. Hopefully you have the software because you present the midterm. If not, similar that in the midterm, I am giving you a link on Canvas. You can access the link. If you have the software, open the link with the software and you're going to be able to test everything is working with a small sample exam, 1 question, just to check that everything is working. If you do not have the software, the link is going to give you access to where to download and well, you follow the instructions to install the software and so on. Similar things that you did with the midterm. There were no issues with the midterm, so I hope that it's going to be something similar with the final. Please review that the software is working. If you install some update in your Windows, there are reports that the last updates of Windows 10 cause some issues with the software. So maybe you also need to update the software. I do not know. But my recommendation between today and before the exam Wednesday, test your software in the computer that you're going to use to run the exam. You do not want to be sending emails at 1:30 Wednesday to tell me that you cannot access the exam. There is nothing that I can do. So check your system. Check the browser. April 21, final exam. I am going to talk a little bit about the content, but basically is a comprehensive exam, everything included. Good idea to review the midterm review, plus whatever we cover after that I am going to talk about it. In fact, the homework that I am asking you to do, this one, is going to help you to check your knowledge about the last topics that we cover. Patterns, class diagrams, and class diagram match with source code. Those 3 things are key in your exam in the second part, not the only thing, but the things that we review after the midterm, and they are going to have a high impact in your final grade. So the homework is going to help you to review that. Again, my advice, try to do the homework before the exam. That could be great, but it is not mandatory. You have 1 week to work. So exam, the homework, 6 quizzes. I am going to stop with that. So basically, moving 1 slide. So far, I am going to stop with 6 quizzes. With this assignment, we're going to have 6 assignments, and therefore, every single quiz and every single assignment is 4.1% of your final grade. You can do the math, right? All your numbers are on Canvas, so you can calculate the average of your assignments over 25%, or you can calculate every single assignment over 4.16, 16, 6, 6, 6, 6, 6, 6. just to complete the number. So you can calculate your grades, and you have 25 here, 25 here, one that you are still going to submit. You have the 25 for the midterm, the grade is there, and this is your final. Again, I think by now, what you should plan is for the assignment number 6, for this one, it's going to be very easy. My expectation is most of you, if not all of you, submit on time and get a good grade. This is your assignment to recover, to get this 100 over 100, and therefore get this 4.16% that you can directly add to your final grade. That is the opportunity to improve your grades. Hopefully you take advantage of this. So with that, you can calculate your numbers with the others, with your midterm and so on. And I think you can have a very good idea if you are going to be in the A, B, or C space. Obviously, calculate the plus, minus, or nothing is very hard, but at least you could have a very good idea where you are in this A, B, C, and how many work do you need to do, how many preparation you need to maybe move from this to this or from this to this, I don't know, or well, obviously to reach the A+. Check your numbers, calculate your grade. If you have any question about how the numbers should be calculated, please let us know. Hopefully it's easy, use percentages, but any question, anything that is different, that whatever grades you are used to receive, please ask the TAs, ask to me, so you can have a clear idea of your current grade and what do you need. No more classes after the final. This is the last week of classes. Next week, I am sure that you're going to have other exams. So for this course, today is our review. Next one is the final exam, and we are done. I am going to be sending you emails next week with your final grade before I publish those grades in my ASU. So with that, we finish. Good. So review your grades. Talking about this, in particular quizzes, a question that I have received is about accessing your previous quizzes and access the midterm. And let me be clear, you have access to your quizzes and you have access to your midterm. If you have any issue or any problem figuring out how to get access to them, please contact the TAs. They can help you with Canvas. But you should have access to your quizzes and your midterm. Now, to be clear, you have access to the questions that you receive. So you can check the questions that you answer. You have access to your answers. Whatever you select as an answer is going to be there. So you can know which was the question that you have and also what was the answer that you provide. Also, 3, you have access to know if that answer, the one that you select, is correct or incorrect, period. So the question, the answer, and whether that is correct or not. That's it. Professor, what about the correct answer? The correct answers are in the lectures, in the slides, or ask for help. Let me be clear. The correct answers are not there unless you answer correctly the question, obviously. So your answer is the correct one. But I want to avoid memorization. We have a lot of cases, in which someone sent an email and basically an appeal. And the appeal is, Professor, in the midterm, I have this question. And I know that the correct answer is this one. And the same question is in my final. So I answer the same. And in the midterm is correct, but in the final is not correct. So the exam is wrong. Memorization. So that is the reason because I am not giving you the correct answer for the exams. I want you to read and, okay, if you get this correct, you know it. If you get it incorrect, well, you need to figure out how does it work addition and then figure out things. It's more about review and comprehensive what happened instead of just remembering the answer, because honestly, we do small changes like this and we do that thinking that it's going to be an easy thing to do, use subtraction in terms of addition, but some people, sometimes crazy things happen, right? And then the appeals. So you have access to the question, you have access to your answer, that's it. Any additional doubt, please contact us. Good? So the exam, as a summary, the exam is comprehensive. So the first thing that I could recommend you to do, besides reviewing your quizzes and the midterm, the questions, is go and check the lecture 16. In the lecture 16, I do a full review for the midterm. So if you review that, it's a full review of all the lectures from 2 to 16. So the only thing that you need is to add from 17 to today, 26. So it's like 9 lectures to review. For those 9 lectures, let me be clear, it's the practical part of the class. So the first 16 lectures or 15 lectures, we review concepts, papers, and we do some practice. But as you remember in your midterm, it's kind of a balance between practical questions, programming, and also a lot of theoretical questions. Those theoretical questions can be there again in your final. Those practical questions, the easy ones, can be again in your final. What else? What else? These things. 4 things that you can add to what we review in the midterm. And that is what we did from lecture 17 until the previous one, until today. We have been working with design patterns. And for the design patterns, something that I will recommend you to be sure that you remember is the class diagram and the coding for the design pattern. If I mention observer, chain of responsibilities, decorator, are you able to remember to picture in your brain the diagram? So if I give you 4 diagrams, could you point out the one that correspond to the pattern that I asked you? Hopefully the answer is yes. Something that we review is the key parts of the diagrams. What is the most important part in the singleton? What is the most important part in the decorator? What is the difference between the decorator and the chain of responsibilities in the design? But if you remember the design, also, hopefully you remember the key parts in the coding. Key thing to do for a singleton. And that was a question in your midterm. Hey, I have this class cat, and these are the methods and the variables. Can you convert or transform cat to a singleton, or Blackboard to a singleton, or TV to a singleton? Or can you make this computer observable, and can you make that person observer? Those kind of questions, but now extend to the new patterns that we review. Decorate, chain of responsibility, composite, and so on. Factories of something, builders for something, all of that. Most than doing a review here and mention again things that are recorded in previous videos, my request for you is, if you remember the diagram, if you remember the code, good, you are done. If not, take a look to the slides. The code is there, the diagram is there. If you need more details, take a look to the video. All the classes are there on Canvas, so you can rewatch the lecture if you need it for a particular pattern. Something that I did with the videos, they are edited, and in some point, there are some kind of message in the lower left part with a title about what I am talking about. So you can notice the name of the pattern, so you can notice that I am talking about the assignment or something, so you can move quickly into the video. You do not need to watch the full lecture, but just locate the topic that you want to review. So design patterns, the coding, and the diagrams. Similar, I have a question there, client server, similar idea. There is not a class diagram. I am going to move here from the design pattern to the architectural pattern. For the architectural pattern, similar idea, but without the class diagrams. There are no one class diagram for an architectural pattern. For the architectural pattern, we review these block diagrams, the architectural diagrams, only boxes with lines, no UML. However, we review some options for implementation. In particular, we review in deep model view controller and Blackboard. because I asked you to use those for a particular implementation. We review from the block diagram to an idea of a UML diagram to source code. For the client server, I am aware that we didn't do any project with that. However, we review one simple implementation in Java with socket for a client and a server. So client, server, they communicate, socket, server socket. If you copy paste the source code that I give you, if you take a look to the link of the tutorial that is there, socket with Java, that is the only thing that you need to know. Something simple, at least one example of how the things work. Moreover, I think in the lecture I mentioned that internet or the net is not one element in the block. You do not represent the internet as one block or one element in the diagram. Hopefully you remember that part. Probably that is the most important thing for you to remember. Internet, the connection, period. There is not a class internet. Your classes are socket and server socket and your application and so on, but internet do not translate to a class. Things that we reviewed there. As usual, any question in your exam is going to be about something that we talk about or review during a lecture. That was my promise for the midterm. Any question that you review in the midterm, we talk about it. For the final, the same. If you have been here or you have listened the lectures, if you have been answering my questions in the chat, anything in the exam is going to be new. And hopefully most of the questions are going to be easy to answer. Challenge, some programming, yeah, 10 lines, 15 lines, probably the most challenging questions there. You can expect coding, yes, mostly you can expect understanding the coding. Most of the coding that I am going to ask you to do is related one way or another with patterns, but also I am giving you coding, I am giving you small parts of Java code, and I am going to be asking you for the class diagram, or I am going to be asking you for if any pattern is there. Use as a multiple choice questions, which pattern is there in the source code. So yeah, I am highly recommending you to review the source code. Again, if you copy paste and understand source code that I have shared with you in the slides during the lectures, you can make it. And talking about the client server, the same. I share with you source code in Java for the client server, one example. If you are able to understand that source code, moreover, if you are able to create a class diagram for that source code, like for any other, that is what you need, nothing else. Good. Talking about programming, anything in the slides can be there, and your assignments. I am assuming that you work in your assignments, you did your assignments, so key component of your assignments could be things that we use for questions. So be sure, if for any reason you receive help to do your assignments, if for any reason one small part in one assignment is something that someone helped you, please be sure to review and understand everything in the assignment, because our assumption is that you work in the assignment, you did the assignment, therefore we can ask you about things there, the programming things, graphical user interfaces in Java, for instance, given that you have been doing panels and frames during the full semester. Yeah, the question in the chat, yes, I am assuming that there are two variables. One variable B that is global is a diamond for B with the class B. If you have another class that is local and the local one is with whatever, including B, that is another relationship. So yeah, the global have a line, the local have a line. Yeah. Good. Okay, things like that. Those are the questions, the tricky questions that you can expect for the exam. Be sure that you understand how things work. Most of the things are use mechanical translation, is just follow the process. If you remember the process, everything is going to be fine. Now, other things beside patterns, architectural and design patterns, we talk about smells. not only the lecture that we have about the smells, one lecture that I shared with you, but if you remember, there was this couple of lectures that I used to show you your own implementations of a particular assignment. I use sometimes during the lecture to show you solutions for different teams, maybe your solution or your classmate solutions. And we talk about errors. There was a lot of effort that I tried to put in sharing with you, not only the theoretical background and the good practices and the nice solution, but also to talk about solutions, your own solutions or your classmate solutions with errors. There are always errors, but when we saw the error in the source code or the diagram from another person, it's easy to identify the error that when we are working in our own assignment. So what I did was to share with you this set of different things that smell more than errors, because finally the software was working, but things that can be improved, things that were not exactly at the standard tell you. So if you have time, the other thing that I would recommend you to do is review these slides with all the diagrams that I shared with you, in which I mentioned, hey, there are errors there are smells there. Sometimes I didn't have the opportunity to complete the lecture and talk about all the different diagrams or all the different problems. At least in the last lecture, I shared with you more diagrams than the one that I use. My recommendation, use that to practice your knowledge, to be sure that you can identify problems, because another type of question that you can have is use like that. This diagram here, what can you do to improve it? This diagram here is clean, keys, repeat things, make sense, smells. Put the question in the way that you want, but we're going to ask you to identify problems in diagrams or in source code. We review both. So check, test yourself for that skill. And if you have any scenario in a diagram or any scenario in source code in which you are not sure about the answer, ask before the exam. Share with me the screenshot, share with the TA the screenshot. Professor, this is good or not? I think that there is an error in the line 12, yes or no? And those kind of questions are easy for us to just follow and say, yes, you are fine. No, check that, something like that. So review things. You would like to do that before the exam. The final topic, the one that we studied in the previous lecture, model-driven development. There are going to be a few questions about it, about the theoretical background, but more important, about the things that we're going to review today, because this thing is highly connected with design patterns. And that is the reason, because that is our last topic, is the practical use of design patterns outside with some kind of framework. So those four, plus the review that we already did about the theoretical things, are my recommendations for you to check before the exam. I hope that you already start reviewing things, that you spend your weekend or some days, previous week, Friday, today, tomorrow to study. But that is the exam. Open questions, programming, questions about concepts, questions about this is correct or not, what can I do here, improve, etc. And multiple choice questions. Multiple choice questions, both about this, which is the pattern in the picture, and you just select which one is, which of the following are architectural patterns. Your last quiz, if you complete the quiz, a lot of questions from the last quiz are going to be in your final exam. So that quiz, quiz 6, give you a pretty good idea of what can you expect with regard of these topics, because that quiz cover not this, but the other two. And you have a feeling about the question, right? Most of the question in the quiz, multiple choice, the only thing that is going to happen, just imagine that kind of questions, but open, just like the question in your midterm about doing the cat observable or the dog, whatever was your exam, or making singleton a TV or whatever class you have in the exam. So think about that combination, and that is going to be your exam. It's only 75 minutes, so we are not going to ask you to write kind of a lot of code or a lot of open questions, it's going to be a good balance. Remember, just like in the midterm, average, I cannot promise you numbers. There are not a magic number, but the average is 20 questions, more or less. The average is that you could have kind of 3 minutes per question, again, kind of, but the open questions, you need more. 5 minutes, you can finish with those questions. The multiple choice, usually the average student, and we're in less than 1 minute. Which is the pattern in the picture? You have 4 options, click. That is going to be worst case scenario, 1 minute. So the time is balanced. The same exam have been done before by other students. The time is not an issue, believe me. It's not an easy exam, but no one have complained so far about the time. It's more about preparing for the exam and having knowledge of the topics. Good. So, okay, how many questions? Around 20. Research papers, good. I am not going to ask you about the research papers, anything that we do not review during the lectures. So again, if you remember the research papers, I asked you to read, and then we talk about them during the lectures. Some of the things from the papers are in my slides, summaries, and other topics, important ones, a few of them, we talk about it, even though there is not a slide that have that particular item. So if we talk about it during the lecture, can be the exam. If not, it's not going to be there. So the only tricky part, guys, is I am telling you that all the topics are in the lecture. A common mistake is if you miss a lecture and you think that you can replace the lecture just reading the slides, that is not true. Because we talk more things than the things that are used in the slides. The slide just mention a few words or a few things, but the discussions that we have is more than just the slide. So, Professor, I reviewed the slides and that topic was not in the slide. Well, but we talk about that in the lecture and sometimes in an empty page like this, right? Every question in your exam is something that we review during the lecture. If you miss a lecture, review the video. Highly recommended, because there are information that is not in the PowerPoint, but in an empty page like this one that we discuss or we review or we complete or something. How many questions? I already answered that. Okay, good. So that's it. Now, final topic, moving forward. I talk about this in the previous lecture. I talk about the tool, I talk about the different steps in the tool, and hopefully by now you have the tool in your computer and you have the opportunity to use the tool. If not, don't worry, you have time. That is part of your homework. So if you get the tool and you run the tool and you are in the point in which I finished the previous lecture, you have half of the homework done. If not, well, you have time to do it, because that is the first part. Now, what I mentioned in the previous lecture as a summary, the first part of your homework is, this is my input. This is what I give you as an input. I give you the diagram, remember? So I am going to work with this input. This is the system that I want to develop. And that input, in order to put the input in the tool, I have two options. In the tool, I can draw this diagram, or I can input the diagram without drawing. I can input the diagram, this diagram, as a tree. I can input the diagram as an XML file. And I mentioned how to do that in the previous lecture. So hopefully you have the tool and you were able to create a new model. And that new model have 1, 2, 3 classes. And those classes have 1, 2 relationships that are exactly the same that I am showing in the picture, but with a different representation, with a different way to input the data into the system. So, professor, what I do with the diagram? Nothing. The diagram is used for me, for you, as a reference of what to put inside of the tool. This is what you put inside of the tool, right? Clear? You put in the tool your classes, your relationships, your attributes. And where are they? In the diagram. You read the diagram, and then you can fill the information in the tool. This is what you have in the tool, period. The diagram is used what I give to you, not for the tool. Next, moving forward, if you have this in the tool, the next thing is you can use this, the model. And this is exactly the same like this, but in a different language, in a different representation. And you can do code generation. You can use the tool, the EMF, to create source code. Step for do that. Basically, what we are going to do is to move from this to this. If you notice, when you did this input here, this branch in the tree is called an E-class. This top is called an E-package. This guy here, the attribute, is called an E-attribute. And yeah, the reference, an E-reference. Why? Just because the tool is telling you these guys are not classes yet, but they are going to be classes, E-classes. Oh, this guy is not a package yet, but it's going to become a package, an E-package, Eclipse, right? So we're going to move from all that, guys, the tree, to real Java source code. And that is going to be the work of this tool using a code generator. We did a code generator, or we tried to do this with compilers. So it's not rocket science to do code generation. The tool gives you one. What are you going to do in your homework? Well, very simple. You are going to create, you're going to use one of these to create source code from the input that you provide. What this guy is going to give you, is going to give you 4 plugins, 4 packages. Okay, we're going to start with this tree. We're going to use this tool, and the output is going to be 4 packages. And those 4 packages inside are going to have classes, several classes. But there are going to be 4 packages. Using the Eclipse fancy words, they are going to be 4 plugins, 4 packages. The name for the packages, and remember this because we're going to have them later, there is going to be a package model, edit, editor, and test. Test like test cases, unit test cases. Yeah, the tool is going to create unit test cases for you, for your classes. Edit and editor. Those looks like graphical user interfaces. Yes. Edit and editors. Places to edit and places to show your data. Graphical user interfaces. 2 packages for that. You are going to be able to take a look. And the most important, the core of everything, if you remember model view controller, the most important thing, the source code for your classes, the model. Okay, those are the important ones. Yeah, those are the important ones. The others, additional things that you can use, additional things that we can review. Good. What I do to create source code from the input that we already provide. I am giving you the slides with the steps. Professor, I do not know how to use the tool. Two options. You can go and search for a tutorial, or you can just read the slides. In the slides, I am giving you what do you need to do. What do you need to do? Remember that you have here a project in the background. Right-click in the project and follow these ideas that basically is right-click. You know what? I need a new generator. And with my new generator, the tool is going to ask you for a name, and then it's going to ask you for a category. You be sure that in the category you select this, eCore model, eCore, yeah, all those things that we have, ePackage, eClasses, eReferences, and so on. That is the eCore model. So we're not using a UML diagram. We're using that thing, the tree that have everything, an eCore model. That is the fancy name. So we need a code generator, new one for an eCore model as an input, and then you go and save your code generator, and you connect your code generator with your input. That, if you remember, at least in my example, I put this name of my model. So a new code generator for an eCore model, and you know what? The eCore model is the one that I already have here. Done. And then you may click here, and you're going to have this menu. And new items in the menu is that now you have your code generator, and your code generator is going to give you the possibility to say, what code do you want to create? Everything? Or maybe you just want the test package. Or maybe you want only the editor package, or maybe you want only the edit package, or only the model package. My recommendation, the idea is to review all the possibilities. Select this one, ask to create everything. So did you notice we just create a new code generator, we add that in the project, we connect that with our input, and then we just go run. You will notice that here, you have almost nothing. The only thing that you have here is your model. That is exactly the same that you have here in the middle. And when you click generate code, when you click here, you're going to have something like this. This here and these three here, the things that I put there with a yellowish background, those things are new. And those are the result of the code generation process. Really? Yeah, really. You have this thing here, my model. Why the one at the top is bigger? Because I opened the folder. You will notice this thing is open, all these are closed. So originally, all of them are going to be closed, and you're going to have these 4 packages. What I am doing is to open the important one, the model, and you will notice that inside, what we have is basically source code. Source code, like in any other Eclipse project, we have a folder source. And inside, for the model, we have 3 sub-packages. So we create one package with the model that is going to be everything that we need. And inside we have 3 sub-packages, and remember the names. One package is the model per se. The other is something like model implementation, model input. And the other one is some utilities. 3 things used by default. Wait, are you telling me that the input was this one? This thing was the input. And that input represents these beautiful 3 classes here. 3 classes. But the source code that you are creating is 4 packages. Well, but this is testing and these are graphical user interfaces. Okay, 1 package. But that 1 package has model and model implementation and utilities. Yep. a lot of extra source code, a lot of extra things there. And I want to review with you those extra things there. Clear so far? Input, code generation, source code in Java. Are you able to do this? It's going to be your homework. Okay, I have at least one yes. So 2 yeses, okay. Hopefully everyone else, 40 people, okay, good. So next. Okay, very good question. It's going to be individual. So your assignment is going to be individual. I want to be sure that all of you have the opportunity to play with this. And as I mentioned before, it's something that one person can do in a couple of hours. So doing this in a team, you are not going to be able to really work with your team. Probably what is going to happen is only one person is going to do it. So individual assignment, all of you hopefully have the opportunity to play with the tool. Good. Don't worry, I am going to give you one slide with exactly what I want you to submit. But now that you're asking, the most important part of your submission, I am going to ask you for the class diagram of this source code. What? Yeah, you are using a class diagram to create Java source code. And I am asking you, from this source code, create the class diagram. The tool is not going to do it for you. It's something that I am asking you to do. From this class diagram, it's going to be the same that this one? It's going to be the same that the original? Yes or no? Bad news, and I am going to put this. It's not going to be the same. Common error, guys. Professor, you asked for the class diagram, but it's the same that we use as an input. No. Why not? Because the tool is going to improve your model. The tool is going to give you more code and probably more quality than the one that you use as an input. For instance, this is our input. This 3 class diagram with 2 connections, trivial, simple thing. What you're going to get as an output is, yes, those classes, but with a lot of patterns and utilities around. And when you create the class diagram for that, your class diagram, the class diagram that corresponds to the output that you're getting is bigger than this. Clear? Why I am asking you for the class diagram? Number one, I want you to practice source code, class diagram, how to create them. 2, because there are going to be a lot of patterns involved. I want you to identify those patterns. And finally, because you can play with this model-driven developing tool. Good. So that is the most important output or submission thing, a class diagram. Not this one, but the real one, the one that corresponds with the output that the tool is giving you. Other than that, I am going to ask you for some screenshots. Screenshot just to be sure that you use the tool. So I am going to ask you for a screenshot of things like this. But the most important thing, the class diagram. Good. All the new things that Eclipse add, yeah. Good. I described this in my previous lecture, but how to create this? The XML is just the format in which this is going to be stored. One of the things that you need to do is to click save to save this tree, but you input this just like we described in the previous video, in the previous lecture, click new class, click new attribute, click new relationship. So all of this you create use in the graphical user interface, adding things to a tree. Just like creating new folders or new files in your operating system is very simple. That's it. Even though it's going to be stored as XML, but you do not need to know XML in order to do this. That is what is working in the background, right? So That's it. When you translate this to source code, the file that is translated is the XML file, even though what you create is this. To be honest, even if you draw a UML diagram, the UML diagrams in the Eclipse tools, they are also stored in some XML language version. So when you create source code from the diagram, it's not really from the diagram, but from this XML file. So that's it. I am going to talk about the questions because I need to show you the source code. Most of the questions about this are going to be related with the source code. So far so good, right? The model, source code. Okay. Let's review the code. Why review the code? Because I am asking you to create a class diagram. So it's a good idea to take a look to the source code and be sure that we understand what is happening there and how that is represented in a diagram. So the code. The first thing that I want you to notice is that you have some packages in the model. And in particular, you have a package that have the same name, my project model or whatever, but there is another one with this prefix implementation. So you have packages, whatever is the name of your project, in the model, the one that is model, and also the one that is model implementation or model imp PL. And also you have this package util, and inside of util, I do not know if you identify that there is someone with this name. And I am going to go back here and did you notice that guy? What do you think is that guy? It's an util. It's a factory. That name ring the bell. It's a factory. We remember something factory. It's a factory of what? It's going to be a factory, and it's going to be a factory of computers. It's going to be a factory of courses, and it's going to be a factory of students. Those are the three classes in the diagram, right? We're going to have a factory for them. Okay, you have a factory for them for free, among other things, and you're mentioning adapters and other things. But factory is obvious because of the name. Wait, did you notice that we have this course, computer, student, but also we have this computer, imp, course, imp, student, imp? I do not know if you are able to notice the icons, these icons here and these icons here. What do we have in the package model, and what do we have in the package model input? Can you guess? Interfaces, yeah. We never ask for interfaces. In the input that we use, in the diagram that we create, the only thing that we have was 3 classes. Why the tool is creating interfaces? Because it's a good practice. Yes, polymorphic behavior. What the tool is doing is, okay, you need students, computers, courses. Let's create one interface for them, and let's put the interfaces in the model. That is really the model. Well, but you are creating also attributes and methods. Let's do an implementation of those interfaces. I give you the interfaces, and I give you one implementation, but you can do more implementations. polymorphic implementations, just by default. That is the way that it works. Moreover, let me give you a factory. So you have a factory, and every single time that you need to create a new student, you do not need to worry for the new. You are free to use the new. Obviously, if you do the new, you are going to do a new student implementation or computer implementation or whatever, because the new is with classes. But you can use the factory. And as you can expect, in the factory, you are going to have methods create, just because that is the pattern. You do not need to worry for the news. Instantiate the factory. Well, use the factory. It's going to be something there. Makes sense. So that is the reason, because we have this model implementation, and utilities. Okay, so far, good. I mean, I have interfaces, classes, and factories for free. The factory, usually, in order to use the factory, we need to create an object factory. Can we put together a factory with a singleton? I am talking about the patterns. Can we create a factory or have a factory that is also a singleton? And hopefully your answer is, why not? Two patterns, we can put them together. Something that you're going to notice in the source code that I am going to show you, in the source code that they're going to get, are going to be lines like this. Can you imagine what is happening there in those lines? The name factory, hopefully remember you, that is going to be a factory. Moreover, I have a method create. Makes sense. Inside of a factory, method create. But this instance here is a singleton. Are you telling me that I do not need to do factory something equal new factory? I just need to call the class, get instance, and then call the create method. And according with the create method, I am going to be able to create whatever object from the model that I provide. Yep. In this example, the object is does list, is just a different class, getters, create, setters, and so on. Very simple, right? I do not need to use news because I am not doing the news. Whatever object I create is able to work together with other objects in the Eclipse platform, in the Eclipse environment. Any of my objects, in this case, student, computer, and so on, is ready to collaborate with objects in the Eclipse libraries platform environment. That is the advantage. Yes, and you can imagine like, what is this? Uppercase, a constant, public, static, because the name of the class before, so yes. And how do you know that? Because you know the standards, and because these people is following the standards. You will notice the lowercase e. Well, it's just a small play. If you remember, they are using this e to identify Eclipse, and it's uppercase, and other things are lowercase or words. Here, just because the constant should be everything uppercase to fulfill with the standard, well, they put the letters lowercase so you can easily identify the E that is kind of the signature of all the things that happen here. So this is particular thing of Eclipse to kind of signing the thing, but it's supposed to be everything uppercase because it's a constant. Good. So source code. There is a package my model. You have their classes, one of the classes that you have is this class of this interface course. And if you open the file, I am talking about this file here. Click, click, and you're going to have here an editor with this source code. Did you notice here anything new, complex, different? Or everything here makes sense? And I put the class diagram here for you as a reference, what we ask for. We ask for a class course, and we are getting this interface, and I am going to show you the class also. But you notice something interesting in the interface? There are a lot of getter setters that are not interesting, but there is something particularly like, wow. Yes. What is a list? It's a list, the Eclipse version for the list. Why? Why do we have a list here? And in particular, a list of students. That is the diamond. That is the relationship. Do you remember how many times we implement this relationship? And how many times we play with the idea of, well, if you have an asterisk, it's dynamic, and if it's dynamic, use a data structure, and whatever data structure you want. Well, here Eclipse have a list, and you remember list. Nothing else critical. Now, remember, this is the interface. So far, it's a diamond. We do not have the, for sure, that is black. That is going to happen with the implementation in the class. You're going to have the new. But did you notice the extent? Why we are extending E object? You could tell me all the classes extend from object in Java, implicit. But this guy is extending E object. E object is the interface, the class, that is going to be the parent of every single object in the Eclipse platform. You know what? This guy, my course, the interface for my course, is going to be part of the family in the Eclipse platform. And therefore, my classes can be used in any place, like another tree or a table or some kind of edit area. It's part of the family. I am adding new code to the Eclipse platform. I am going to show you. Anyway, so far, so good. The interface for the factory also have an interface. Remember, abstract factory, concrete factory. For Eclipse, the factory and the factory implementation, they have their standards. All this information is information that you configure when you provide the data, and nothing really new here. Use abstract factory. This one is good. Course implementation implements the interface course. So it's going to override all the methods that I mentioned before. Extend, container. Yes, it's a container of students. That is the philosophy with Eclipse. You didn't ask for this. Eclipse take the decisions. All the classes that have diamonds, they are containers. Container of something else. Something else, whatever is the class related. The most important part here, notice the method at the end. It's a setter. is a setter, set name. Usually, you could, if I ask you for the source code of a method, set name, that receives as a parameter a variable name, I am pretty sure that you know that the source code for that is going to be basically this line. If I ask you for the source code of a set name method, according with your information in CSI110 or whatever background in Java that you have, that is the line that goes inside of a setter. The global variable equal to the parameter. That is the work of a setter. Can you help me guessing what is happening in all the other lines that are not usually CSI 110 related? What is happening here and this condition here? Moreover, in particular, I am curious about this method eNotifier. Yes. It is not similar to the observer pattern. I am going to use that. It is the observer pattern. You know what is this philosophy here? Every single class can be observed. Every single setter method is going to change data in the class. Every single setter method should notify to the observers. Are you telling me that this class course is going to be observed? By who? Whoever. The class course is going to be observed. And every single time that you call a setter, every single time that you change a variable, is going to send a notification. This notify observers here is called eNotify. Eclipse. Notify. Every single setter notify about the changes. Did you notice that every single time that you select something here, you have all the information, all the attributes for whatever you select here in this table? Why? Because all this, whatever is the class, is observable. And whatever are the attributes, they have setters. And all the setters notify about the changes. So it doesn't matter if you change something here or here or here. In every single place in which you are showing that object or the attributes of that object, they are going to be notified. Every single graphical user element in Eclipse, this tree, this table, they are observers, and they can be connected to observe a particular thing that you want to display. The fact that all the classes are observables, and the fact that all graphical user elements can be observers, allow you to connect everything that you create, like this course student computer, as a plugin with the Eclipse environment. Your new classes can be there in the tables, in the trees. They can play with the others. Moreover, they have a common parent, parent, parent. You use inheritance to add whatever you create to the family that already exists in the platform. Polymorphic behavior. Good? Observer. Factory. Singleton. Same class. Did you notice what is happening inside of the getter? I have my class course. I have this list of students, and this is the getter for the students. Did you notice the fancy source code of, let's check that the data structure is not null. Okay, if it's not null, let's put all this here. Okay, let's do the return of the pointer to data structure. You can do a simple return and the name of the data structure. Probably that is the classical getter that you can think about it. The classical getter that we do in 110. A fancy one. Don't worry, you're getting this for free. You don't need to do one the same. You don't need to remember this. You are not writing this. Exactly. That was my next point. The fancy program. Yes. The tool give you that. You are receiving this source code. For you, it's the same if the tool create one line or these 7, 8, 10 lines from the tool. ToString. You're familiar with the ToString. You know what a ToString method do. Did you notice something particularly fancy inside of the ToString? You're familiar with that guy, right? Yeah, several different things being used. I am pointing the pattern, a builder, string builder. Again, maybe you are familiar with this idea. Let's create a string S and let's make S equal to the value of the variable name plus something plus another variable. Probably we do that, and it's fine. What the tool do is this. I am not going to go into the details, but believe me, this is better than you do this addition with strings. You want to do this. There is a reason because you have this string builder. Exactly. You can go into the details of those reasons. That is true. So, again, fancy source code. That is better than the trivial one for good reasons, but automatic of generation. Other class, and I am not going to go into the details, but the notify is not only in one class, it's in all of them. Set computer, get computer, the variable, the other connection. Summary. What you get asking for the source code of 3 classes is more or less 1,000 lines of code. You can review all of them. I am not going to review with you all of them, but that is what you get automatically for 3 classes. 3 trivial classes. How many lines of code those classes are if I ask you to create them manually? 3 classes. How many lines of code to create those? 20? Okay, 100? You are getting this. With all those defensive programming, fancy validations, patterns, etc., and the fancy builders, adapters, and other things that I didn't describe. 1,000 lines of code. If you think about it, $1 per line of code. Because remember, it's like one developer create 10 lines of code per hour. That is kind of the standard. So $10 per hour, $1 per line of code. Use quick maths. You're getting 1,000 for free in 1 second. Should I do all my projects with this? No. It's a big project. You really need all these validations. You really need all these patterns. Is your project something that you are going to integrate with other projects? Moreover, are you going to take advantage of the graphical user interfaces or other libraries that the Eclipse Foundation provide? It's a good tool. You're going to develop the house for the dog, like we reviewed in the first lectures. There is no need for going in this direction. But as you know, several different options, depending on the project, your team, your environment. Is use one more tool for your toolbox. Your homework, as I mentioned before, I show you source code for the testing. You can review if you want, but going to your homework, this is what I am asking you for the homework. This is the diagram that I am asking you to use as an input. The same thing that I described before with this class diagram with courses, students, and computer, the same process. But this is your input. And the most important thing that I am asking you to submit, to give me screenshot of the input. So show me the input, just like I did in my slide. Screenshot of the source code, just like I did in my slides. And the class diagram for the output source code. I am not asking you for this one. I already have that one. I am asking for the class diagram of the output that the tool is going to create. And that's it. I didn't talk about this, so I am going to delete those lines. So only 3 things. Screenshot of the input, like a trick. Screenshot of you creating the source code, your source code there, and the class diagram. Because asking for the class diagram, you are going to work and identify what things are there. A lot of interfaces, a lot of classes, factories, and other things. This is the input. That one is the input. So is computer, CPU, and memory. Those are my 3 classes. And you're going to have a factory for computer, CPU, and memory, and all the things that I described. But now those are going to be your inputs. So you do exactly the same that I did with these classes. You create a class diagram from scratch, you submit that, and that is your last homework. We are done. Creating the class diagram could help you to review if you are familiar and prepared for the midterm, if you remember all these things that we review, composition, association, realization, and so on. So highly recommended that you do this today, tomorrow. And that's it, guys. With that, we finish. Any question? Yeah. If you continue with this, you're going to need some SDKs, some packages. Yeah, I didn't describe the edit and editor. It's something that you can explore more, but basically you can connect the classes, these ones or the previous ones, with tables, trees, and so on, and others, packages and SDKs. Class diagram for, yes, that is correct. For the classes that you have in model implementation, and util, only for that. I do not talk, and I didn't mention test, edit, or editor, so you can ignore that part. Yes. Good. Okay, guys, I am going to stop here. So thank you. Next lecture, your exam, we are done. Next week, I send you an announcement with your final grades. So good luck.